All right, kiddo, here are some skills you bombed on the unit test. The first one, converting rational numbers to fractions. All of these cases of rational numbers are decimals. Some of them are with terminating numbers, and some of them are with repeating numbers, or repeating decimals. So when you convert rational numbers to fractions, you just write it as what it is. So 65 hundredths, you do 65 over 100, and then you can simplify it by 5. So that will be 13 over 20. 625, so you have 6 and then 25 hundredths. 25 hundredths is 1/4, so it's going to be 6 and 1/4, or is a rational number. 6 times 4, 24, 10 plus 1. Well, you know, what am I telling you? 25 over 4. The next one, here's when the fun starts. When you have a repeating number, you're going to look at how many and where those numbers are repeating. You assign the number itself to be x. So x equals 3 and the tail of repeating 15. Since I have two numbers and they are in the hundredth place, I will multiply this by 100, meaning that I will multiply both sides of the equation. So that will give me 100x minus, and I move this and I get 315, and then again repeating tail of 15. And then I subtract the first equation, so x minus 3 and the tail, from this number. So this, I'm subtracting, is going to give me 99x, and then the tails will eliminate each other because it's a forever going tail of the same kind. So that will give me 312 because that's 315 minus 3. And then I do x equals 312 over 99. Now if I add these, then I will have 6. So that's divisible by 3. So I can go ahead and simplify this. It's going to be 104 over 33. Then the next one, again, 25 is the repeating number. There are two of them. They're in the hundredth place. So I can go ahead and start with 100x will be 25 plus the tail minus x, which was initially 0.25, which is the tail. That takes care of the tail. So this eliminates. And I end up with 99x equals 25, from where x is going to be 25 divided by 99. There's nothing we can do here. And then the last one, 0.225 repeating. So 5 is repeating. So this is what I have to kind of hitch off. So even though there's only one number, it's in the thousandths mouthful place. So to move our repeating tail to after the decimal, we'll remember scientific notation, which we'll practice later, that 0.22, for example, is like 22 times 10 to the negative second. So in other words, I will need to remember to divide this by 100 later. My x, I'm going to use a big X, is actually the little x over 100. So I'm going to say my big X is 22 and the tail. Then 10 of my big X's are 225 and the tail. So then x, the big X, is going to be 225 minus 22, 203. So it's going to be 203 divided by 9. That's the big X. Then the baby X is going to be 203 divided by 900. And if you put it into the calculator, you will see that 22555555555 forever. Approximating square roots. So what you need to think of is what the number under the square is close to in terms of existing complete squares. 2 squared equals 4, and then I know that 3 squared equals 9. So the square root of 8 falls in between the square root of 4 and the square root of 9. The actual number square root of 8 is more than 2 but less than 3. And it is closer to 3, so it is definitely, square root of 8 is going to be definitely more than 2.5. And if you use a calc, it's 2.8, so pretty close to 3. Now square root of 32 you know that there is a 25 and 36. So it's between the square root of 25 and the square root of 36. Square root of 25 being 5, square root of 36 being 6. And again, 32 is closer to 36. So it's safe to say that the square root of 32 is more than 5.5. It's about 5.7 probably. Square root of 37 minus square root of 3. So think of where the square root of 37 falls. The square root of 37 is pretty close to 6 because square root of 36 is 6. It's slightly, almost, I can say, almost equal to 6. So let's approximate it's 6.1-ish or maybe 6.2-ish, somewhere over there. Now, square root of 3 is between 1 and 2, but it is closer to 2 because 3 is closer to 4. So then if I subtract something 6-ish with some numbers after the decimal minus something less than 2, then my answer is going to be bigger than 4. So if I were to draw a number line, if this is 1, 2, 3, my answer would be somewhere here. Square root of 65 plus square root of 17. Again, let's guesstimate. This is pretty much 8 in some points. 17 is a little bit over 4. So it's going to be 4 and barely some points. Then on the number line, it should be somewhere between 12 and 13, not over 12 and a half. Somewhere here probably. Now the next one, in and out of square roots. This is when you take numbers out of the radical and shove them back under the radical. Square root of 200. What you need to think of are numbers that you know are perfect squares. You know a perfect square of 100. So think of what you can split 200 into. It could be 2 times 100, then 100 is 10 squared, so you can take it out of the square root. Back into the square roots. 5 square roots of 2. To put 5 under the radical, I have to square it. Square root of 5 squared times square root of 2 is the square root of 25 times square root of 2, which gives me a square root of 50. 8 square roots of 3, again, you put 8 under the radical, you have to square it. 8 squared times square root of 3, which will be the square root of 64 times 3. So it's 180 plus 12. Now, when you are determining where the 2 square roots of 7 is greater than 3 square roots of 5 or less than, shove 2 under the radical, that's going to be the square root of 28. And shove 3 under the radical, that's going to be the square root of 45. So that is clearly less because 28 is less than 45. So when you put it under the radical, 6 square roots of 3 versus 5 square roots of 5. Shove 36 under, square root of 36 times 3, that's 90 plus 18. So 108 versus 5 square roots of 5. So that's 5 times 25, which is going to be 100 plus 25, 125. That means that 6 square roots of 3 is less than 5 square roots of 5. So I hope that helps, and now you just need to do some practice on Khan Academy, and then you can tackle that test again.